Hey guys, Ivan from PARSIQ here, and today we'll be taking a look at how to build a Web3 custom API using PARSIQ SDK. So first of all, let's talk about use cases a bit. So you all know that blockchain data is publicly available, but still it's technically hard to get it. PARSIQ Tsunami API and SDK is there to help you do that. So let's start with a simple voting contract. You might use the data that you grab from your contract for your dashboards, for your UIs, for analytics, for trading insights, and so on. So the applications are limitless. And let's start with a simple example of voting system. So first, let's take a look at the contract that I deployed at Sepolia main testnet for this purpose. It's a voting contract. We have candidates here with IDs, names, and vote counts. Also, we have vote events and new candidate events. And obviously, we have corresponding functions which allow us to add a candidate and to vote for the candidate. So in order to get information about what's happening here, we will need to track events. So let's go back to transactions. We can see all the transactions on Etherscan, and let's first get all these transactions, all these events using PARSIQ Tsunami API, and then proceed to building a more comprehensive solution using SDK. So to use PARSIQ, you will need to go to parsiq.net. We have SDK docs here, we have API docs here, you can sign up here and all the other stuff. So let's start with API by going to the docs. We have a lot of different endpoints. So the endpoints here under Tsunami API, there are 4 raw data, which can be found in the blocks, such as transfers, events, transactions, blocks, contract creates, destroys, and other stuff. And also we have custom Web3 APIs. For now, it's NFT API and balances API, Uniswap API coming soon. So they allow us to see balances and NFT holdings, which is a bit more complicated, and we'll dive in that. So first of all, let's take a look at the events that we want to track. So in order to do that, I will need my API key. So let's get it. We're gonna get it here. So I'm already signed in, and you might want to create an account. I'll copy paste this regenerated key. I'll save it here for later. And let's go back to the docs, to the events endpoint. So let's paste our key here and we're good to go. Now let's see what we need to monitor events. So first of all, we need to specify a chain. In our case, it's Ethereum Sepolia. You can see many other chains here as well, mainnets as well as testnets. The next thing we need to specify is the contract address. So I'll get it from here. Then we need to specify a block range, because sometimes it makes sense to take a look only at the later blocks, but now we'll see all the blocks from the first one to the latest. And then to specify the event, we will need to provide topic 0. So obviously, if you're compiling your own contracts, you have this topic 0, but for this contract already deployed and verified on Etherscan, we will take a look at the logs and copy topic 0 of the new candidate event here. So this is topic 0, and I think we have all we need, and let's try it. All right, you can see that Tsunami API provides all the data to us pretty quickly. So it has all we need, which is topic 0, topic 1, and then transaction hash, block hash, and all the other stuff. And that's basically how you get events, or the same way you can use for transfers and so on. However, in case you need to accumulate, process data, you will need to use SDK, because like with events here, we just get all the data from the blockchain. Obviously, we can process it on our end using some Python script or whatever, but SDK is a better way to do that. So in case of balances, for instance, to calculate balances, we need to go through all the transfers and calculate their sum. And the same way For votes, we need to go through the whole history and sum all the votes that have been done for this candidate, right? Let's jump into that. And to start, we'll need to clone this repository here. So you will see the link below the video, as well as all the other links, documentation, readmes, all the other stuff. I got my empty PARSIQ demo folder prepared, and let's clone this repo. Okay, and let's take a look at what we have here. We have several folders. For now, it's just CNS registry and voting example, but more examples coming soon. We have the basic README in the core folder, which refers us to other folders. And for our case, for voting example, we will need this README. So it tells us that first of all, we will need to change the Tsunami API key in the data lake file. And let's take a look at this file and replace the key also. So as I have said, I have stored it here for later, and later is now. So I'm entering this key here, and let's go through this file line by line after we run npm install, so that we don't see all these warnings, right? Okay, so we have some imports here. We import all we need for that particular custom Web3, which we also call a data lake. Also, we need the API of the smart contract, which I have provided here in a separate file. You can copy paste it from Etherscan as well, in case of some popular verified contract, or you will have it in your compile files. So importing this one. Also, we have Tsunami API key. Don't forget to provide that. And also note that to run a data lake, you will need to send several, if not say many requests to PARSIQ API to get the data. So make sure that you have enough computational units for that. In our case, there were a few events, so I don't need a lot of computational units, but in case of some popular contracts, you might need them. So you get some of them on a free account, but if you need more, just make sure to upgrade your account. Okay, then we specify the network. In our case, it's Sepolia. The contract address is already there, as well as topic zeros for new candidate event and vote event. Then let me scroll down. We have contract deployment block number here. So we don't need to go through the whole history. In fact, we only need to go starting from the block where this particular contract was deployed. And that's why I'm providing the block number. Then the next thing is pretty important, because we specify the data layout in our key value storage. In our case, it's pretty simple. It has a candidate ID, which is a number, a name, and the number of votes. Also, we have meta layout here, but we don't need that for our simple example. And then we need to specify the types of the events within the TypeScript file. So we have new candidate event here with candidate ID and name, and we have a vote event here with candidate ID. Now, for your own example, you will need to replace and redo this stuff. So let me show you what you might also need to replace. So we are inputting our API here, make sure that it's the correct one. We are providing our deployment block number here, and then we're providing all our topic zeros for all the events that we're interested in. So in our case, it's just the two of them, but you might have more. And then for each of those events, we call the corresponding process function, process new candidate event and process vote event in our case. And let's take a look at these functions. So we have topic 0 and topic 1 here, and then we store our candidate in our database using key value storage. So the key will be the candidate ID, and the value will be the structure with all the data about the candidate, which is candidate ID, name, and number of votes. We'll start with 0 because like when we add a new candidate, its number of vote, it's supposed to be 0. Okay, and then we have this process vote event function. Basically, the most important and interesting part is here, because what we're doing is we're increasing the number of votes by 1, and we're storing this information in the database. And also all the other stuff here is reusable. So let's now run this data lake and take a look at how it works. So to do that, we'll go back to our README file. You can refer to documentation and Medium article as well. We've already ran npm install. I've already installed Docker and Docker Compose on my computer. Make sure to do that too. And the next instruction is to build the actual runner image. Okay, let's do that. And the next step will be to run the actual data lake after we have it built. All right, and let's run it. So the thing is, Docker has some strange combination with Postgres, and sometimes it doesn't start the database from the first run, but that's not the case right now. We have the data lake up and running. You can see that it's processing blocks. Now let's make sure that it's processing blocks in the correct way. In order to do that, we will need to take a look at the database. So we also have the instruction on how to connect to the database here. These are the tables that we have. Currently, we're interested in candidate entities. All right. And let's take a look at this table. So we have 3 candidates here, which is actually correct. And we have 2 votes for Ashoka the Great, 1 vote for Cleopatra, and 0 votes for Confucius, which is also correct. You can compare it to EthScan, or you compare it to what we've seen in the PARSIQ API output. And basically, that's what it does. So it monitors all the events of interest on the blockchain, then it processes them in the specified way, and the logic that you might need depends on you, depends on your particular smart contract, whether it's your own or one of the popular contracts, and then you specify that logic, how you store the data, how you process the data, and you have all the data here in your database. Currently, the data lake is processing all the blocks, but when it's done with all the historical blocks, it will continue running in real time and providing you with real-time data. So obviously you can use it for real-time things such as UIs or some trading notifications and all the other stuff. I believe that's the last thing I wanted to share today. Just make sure to contact us in case of any questions. Please use our examples, use our SDK, and in case you have any questions or problems, contact us, and also feel free to add your own examples if you have any to this repository. That's it for today. Thank you for the time. It's been a pleasure to talk to you. It was Ivan from PARSIQ, and have a good day.